So for page 2 of Unit 5, Lesson 1, what you need to recall is a primary trig ratio, and you use the word abbreviation SOHCAHTOA to remember the 3 formulas. And it says for question 4, you've been using the primary trigonometric ratios. There are also secondary ones. Summarize what the secondary trigonometric ratios are. Although this might look very intimidating and it looks really fancy, it's not that fancy. So what secondary trig ratios are is that it's the reciprocal of the primary trig ratios. As a reminder, what reciprocal means is that if you have a reciprocal of 2, you have the answer of 1 over 2. You basically flip the numerator and denominator, okay? And so what we have is that for cosecant, and the short form for that is csc theta, you're going to take the reciprocal, no, not the inverse, the reciprocal of sine theta. And so instead of me having opposite divided by hypotenuse, I'm going to have hypotenuse divided by opposite. Next, I have secant. That's a long form for sec. So sec theta is equal to 1 over cos theta. So it's the reciprocal of cos theta. And so instead of having adjacent over hypotenuse, I'm going to have hypotenuse over adjacent. And lastly, for cotangent theta, I have cotangent theta, which is equal to, as you might guess, 1 over tan theta, which is equal to, instead of opposite over adjacent, you'll have adjacent over opposite. This is how I usually remember it. Okay, so then cotangent is the reciprocal of tan theta, and they both consist of the letter T. Okay, and then I look at my cos theta, and I would think that that's going to go nicely with this one because that makes more sense, but no, it's not. And they made it a little difficult and said, okay, cos theta is the one that is a reciprocal of secant theta. It's kind of like they crisscross. And then for the sine theta, it's inverse with the cosecant theta. So just notice how they follow along, okay? So for question 5, I went ahead and wrote SOHCAHTOA on the page. It says find the following ratios. Don't find angle unless asked. And so we have, well, it says CosY. That means my angle reference is right here. And so with the red pen, I'm going to say, well, that's my reference angle. That's my reference angle. And if we're talking about cos theta or cos y, that means I need to label my adjacent and hypotenuse only. This is my adjacent, this is my hypotenuse. I have cos y is equal to adjacent over hypotenuse. And filling in, I have, well, cos y, I don't have that. And adjacent is equal to 7.2. It would be 7.2 meters divided by 11.4 meters. The meters would cancel out, and it's important that you stop at this point. Why is that? Well, they never asked for the angle, and I just need to stop there. So it's important that you know to stop here, because remember in the question, they never asked you for the angle, but they asked you for the following ratio. So the following trig or the following primary or secondary trig ratios. right, so for the next one, part B, you have cotangent of angle W. I'm going to start labeling with green. So that is my reference angle. And so the 8.7 is my adjacent side because it is a side that is right next to that angle and it's touching that angle. Meanwhile, for cotangent, I know that's dealing with, I'll write it down, 1 over tan W. It's the reciprocal of tan W. And to remind myself, that's going to be adjacent over opposite instead of opposite over adjacent. And so I have the adjacent. I need to identify the 7.2 as my opposite. And so notice that the colors are really important. Unless you're going to write opposite to W and adjacent to W if you don't have different colors of pencils. And so you're going to have adjacent over opposite, which is 8.7 divided by 7.2.
Just to show this for a second, 8.7 divided by 7.2 is technically bad form. And this is how I use the fraction button. So I'm going to do 8.7 fraction button 7.2. I mean, the long way is that you could have kind of multiply by 10 on the top and bottom and then reduce it and whatnot. There are algebraic ways to do this, but assuming you're okay with the algebraic way, yeah, the calculator will give me the decimal version. But if you play around with your calculator by pressing shift and this one, like the fraction button, you'll get the exact fraction. And so you want usually whole numbers within the fraction. So I'm going to change that up to equal 29 divided by 24 as a fraction.
For question 6, it says find the following ratio. So you're looking for cosecant A, and that is equal to 1 over sine A. I'm gonna label my diagram with this red pen, and that's my reference angle. The longest side is always gonna be across from the 90 degrees, so that is the hypotenuse. Meanwhile, this is gonna be the opposite side to the reference angle of A. So when I plug in my values, well, not yet, I need to identify what 1 over sine A is. Because sine A is equal to opposite over hypotenuse, I have hypotenuse over opposite, the reciprocal version. And so my hypotenuse is 680 and my opposite is 480. Again, that is not reduced. So for proper format, I need to reduce my fractions. You can do it algebraically or use a calculator and the fraction button to do that, and you will get 17 over 12. So in terms of trying to do it in your head, I would have done 68 divided by 48 because the zeros cancel out. And then with 68 and 48, you can try to divide it by the highest factor that you see, and you can divide 68 by 4, and you would have gotten 17 over 12 that way as well. For question tanB, for question B of question 6, if you're dealing with tan, that means you're dealing with opposite over adjacent. So with my green pen this time, or pencil this time, I'm going to put my reference angle at B. I'm only going to label opposite and adjacent, so I'm not going to label the hypotenuse. The 480 is opposite, and the 480 is adjacent. Meanwhile, if I just do that, I plug in 480 divided by 480, it's the same number, and so any number divided by itself is equal to 1. For both question 5 and 6, notice that you're calculating for the ratio and not for the angle, and that's why I'm not doing tan inverse in this case. If there was one more step to this question and it said find the angle B, angle A, you would have to do, let's say, tan inverse or sine inverse after following some algebraic steps if you needed to do this. Question 7 says, if sine theta is equal to 1 over 4, then show how to find the value of cosecant theta and secant theta. So notice that if you have sine theta is equal to 1 over 4, what I usually like to do is, it's basically you can split up any number as a fraction, right? Even if I have a number like tan theta is equal to 5, well, the 5 has a numerator of 5 and a denominator of 1, so I can always still break it down. So that's why it's important that you can always break it down to a fraction as a rational number if possible. So the 1 is the opposite, and the 4 is a hypotenuse based on my SOHCAHTOA. Because what that means is you're basically given that for some sine theta, so for some angle, that its trigonometric ratio is equal to 1 over 4. If that's the case, that means that my 1 is represented by opposite and my 4 is represented by hypotenuse. I'm going to keep going again. I don't need to be finding my theta. That's not really important. They're asking me for the values of cosecant theta and secant theta, which is just the secondary trig ratios. So first, I'm just going to go in order, and I have cosecant theta. So from my memory, I say, okay, cosecant theta, that's the one where you think it's 1 over cos theta, but it's not. It's 1 over sine theta. That's honestly how I remember. And then you think oppositely, right? And so you basically have the reciprocal of sine theta. So instead of having 1 over 4, you have 4 over 1. And therefore, you have cosecant theta is equal to 4, like so. So that was relatively pretty simple, hopefully, because all we had to do was take the reciprocal. So that was good. But for the secant theta, there is a couple of steps involved. So step 1, what I'm going to do is identify what secant theta means to me. So secant theta means to me, well, it's 1 over cos theta. Meanwhile, well, cos theta is SOHCAHTOA, so this one right here, it's adjacent over hypotenuse, but it's a reciprocal, and so it's hypotenuse over adjacent. And so next, I'm just going to write that, well, I know what my hypotenuse is, so I'm just going to plug in the 4 for hypotenuse, but I'm noticing that I'm missing the adjacent. So I need to go ahead and try to solve for adjacent if that's possible. So I am going to draw a right angle triangle with this fancy notepad. And for this triangle, you're kind of making it so that it's convenient for you. It doesn't have to be exact. It's very much a sketch. So I usually start off by drawing my best right angle triangle, and I draw my theta, which is my reference point. So for my triangle, I need to label it. And so I have my adjacent here, but that's the one I don't know and I want to figure out. And meanwhile, that side is the opposite. And do I know that value? I do from the original question. And meanwhile, I also know the 4 for the hypotenuse. The hypotenuse is 4. So when you take a look at this diagram, you should be noticing that, well, you have a side, and you're telling me I need adjacent. So hopefully that's screaming at you that you need to look at the Pythagorean theorem. And so what I have is a squared plus b squared is equal to c squared, and I'm going to start plugging the things that I know. So for one of my sides, I have 1, and I don't know the other side, and then I know my hypotenuse is 4. So I have 1 plus b squared is equal to, well, 4 squared is 4 times 4, which is equal to 16. I need to get my b squared by itself, so I'm going to have b squared is equal to 15. I'm not done yet. I need to get the b by itself, and so I need to square root both sides, and I will get that b is equal to just a positive version, and so b is equal to square root of 15. And my rule of thumb is that I usually like to keep everything exact until the very end, and then if it's a word problem and it's a situational problem, you might round, but if you look at the question, it looks like a very algebraic problem because you're dealing with the ratio and you're not really dealing with the sides. You're not asked to find the sides as your final answer. You're asked to find the right ratio, and naturally, ratio is usually written in fraction form. So that leaves me to step 3. Well, for step 3, what I need to do is kind of gather everything that I know. And so basically my B, that is my adjacent. And so I'm going to go back to my diagram and say, well, that's going to equal to square root 15. And so as my step, what I'm doing is I'm going to sub B is equal to square root 15 to equation 1, because that is my adjacent. And so what I have is secant theta is equal to 4 divided by square root 15. So you could probably realize at this point why we're doing trig now by unit 5 and not earlier. Well, you needed to know how to rationalize, which you learned in previous units. So reminder on how to rationalize, I'm going to multiply the top and bottom by square root 15. That is allowed because I'm doing essentially times 1 over 1, because square root 15 over square root 15 equals to 1. So that's going to help me rationalize, which means that I'm not going to have any radicals in the denominator. And so what I have as my final answer is 4 square root 15 divided by, well, square root 15 times square root 15, well, inside that's going to be a perfect square basically, and you square root that, and you're going to go back to 15, and that's why we rationalize in this manner. And so we are going to have secant theta is equal to the following, and a lot of students are forgetting, but notice, will there be units associated with cosecant theta or secant theta? No, because if let's say the opposite side is 1 meter and it's divided by 4 meters, notice how the units cancel out, and I have no units for this. Meanwhile, for when it's a side length, yeah, I did need to have the units. That's why it's really important that you are writing your units when there is a unit. Okay, do you get what I'm getting at? If it's a side length, yes, you do need to indicate the side length. Question 8. Okay, I have if cotangent theta is equal to 0.4732, then what is theta? Okay, there's a calculator tip. The calculator tip is you have sine, cos, and tan buttons. It's the primary trig ratios, but you do not have it for secondary trig ratios, cosecant, secant theta, cotangent theta. Well, primarily because the secondary trig ratios is the reciprocal of the sine, the cos, and the tangent, right? And so why waste space on the calculator and create the same buttons that mean the same thing? And so algebraically, you need to know how to convert from one thing to another. So if I have cotangent theta 0.4732, how do you convert that to tangent? Well, you look back at this part, which is what we keep kind of referring to, is that, well, then you actually have tan theta, and more so 1 over tan theta, is equal to not just 0.4732, but 0.4732, like so. Meaning 1 over tan theta is equal to 1 over 0.4732. You think cotangent theta is equal to 1 divided by tan theta, and therefore whatever cotangent theta was, you take the reciprocal of it. At this point, I want to get tan theta by itself. Well, the easiest way is if we cross multiply, you get tan theta is equal to 0.4732. At this point, you want to get the theta by itself. And how are you going to do that? To get rid of the tan, you're going to take inverse of tan to cancel these out, and you're going to get theta is equal to, and you're going to do tan inverse of 0.4732, and you're going to get 25.3 degrees approximately. And that is our final answer.